Okay, so what we're doing today is we're going to be doing inverses of matrices and matrix equations. So in the last lesson we saw that if two matrices have the same dimensions, 2 by 2 and a 2 by 2, you can add or subtract elements that sit in the corresponding places, right? So for example, there's a 2 by 2 matrix being added to another 2 by 2 matrix. So then you would just do 1 plus 4, right? Super easy stuff. 2 plus negative 1, and so on and so forth. So they do have to be the same size if you're going to add or subtract them. Then also, remember in the last lesson we saw that if two matrices have the appropriate dimensions, then you cannot multiply them. So remember, this is what happens when you're multiplying two matrices. The inside has to be the same dimension, so 3 and 3 on the inside, and then the outside will be your new matrix size. So for example, if we have 2, 1, 0, negative 1, 3, negative 2, that's a 2 by 3 matrix, and then we're timesing it to the negative 1, 0, 2, this 3 by 1. So we can multiply them because 3 and 3 are the same. So our new matrix equation, or new matrix, will be a 2 by 1. So let's review how to multiply this matrix together. So 2 by 1 here. So that means 2 rows and only 1 column. So do you guys see how that would be kind of the setup? So then remember, this is the first column, or the first term, first column, first row, first column. I don't know why I'm having such a hard time this morning. So I'm going to go to my first row, and I'm going to times it to my first column here. So you'll do 2 times negative 1, which is negative 2, plus 1 times 0, so 0, plus 0 times 2. So we would get negative 2. Then we're going to our second row, first column. So we're going to take our second row and multiply it to our first column. So then we have negative 1 times negative 1, which is 1, 3 times 0, which is 0, and then negative 2 times 2, which is negative 4. So we get negative 3. Did everybody have an okay time with the homework? Okay, awesome. So pretty easy stuff if you know what you're doing with that. Now, a couple things to note for this lesson is what a square matrix is. A square matrix will have the same number of rows as columns. So these are all examples of square matrices right here. Here is a 2 by 2 matrix, 2 rows, 2 columns. Here's a 3 by 3 matrix, 3 rows, 3 columns, a 4 by 4 matrix, 4 rows, 4 columns. These are considered square matrices. An identity matrix, another key word to note, an identity matrix is a matrix that has a main diagonal of 1s. So right here, notice here's my main diagonal of 1s, my main diagonal of 1s, my main diagonal of 1s, and then the other elements as 0s. So basically, guys, isn't this considered reduced row echelon form? Reduced row echelon form, reduced row echelon form. 1s on the diagonal, 0s above and below. That would be what's considered an identity matrix. Now, what an identity matrix does is it will work the same as taking a number and multiplying by 1. If I take 5 times 1, don't we just get back out 5? So that's exactly what an identity matrix will do. If you take an identity matrix and you times it to a matrix, what's going to happen is the exact same matrix will come out. So it's just like multiplying by a 1. So we could go through and do the math here. Notice I have a 2 by 2 matrix multiplied to a 2 by 3 matrix. So I'm not going to go through it. I'm just going to hope that you guys can see it. So I'm just going to kind of show you a look right here. So we would have our first row to get this element right here. We would say first row, first column. So I'm going to highlight my first row, first column. 0 times 3 is 3. 1 times 3 is 3. And then 0 times negative 1 is 0. So do you see how when we add those, we just get 3? And then the same thing will happen here. Here's my first row, second column, so I'll take my first row times it to my second column here. So that would be 1 times 5 is 5, and then 0 times 2 is 0. So that's why we're just getting the same stuff back over again. Does that make sense? Because of those 1s and 0s in the appropriate spots. So if that's true, if you take an identity matrix and multiply it to a matrix and get out the same matrix, what's going to happen if you take two matrices and multiply them together, and you get the identity matrix, what that would mean is they're inverses of each other. Essentially, if you take two matrices and multiply them together, and you get out the identity matrix, you're kind of undoing them. Does that make sense? Inverses undo each other. So if you take a matrix and multiply it to a matrix and get out the identity matrix, they are considered inverse matrices. So look, let's do what A times B here and see what happens. Which I'm sure you know what's going to happen. So Maybe you just want to watch because I think you know how to multiply matrix. So then you'd say, can I multiply the matrix? This is a 2 by 2 matrix. This is a 2 by 2 matrix. Yes, we can, and our new matrix will be 2 by 2, so I would write that out for myself. I always do. I set up my blank matrix. So 2 rows, and then it looks like we're going to have 2 columns. So this is what it will look like. Let's go to row 1, column 1. Row 1, column 1. 2 times 3 is 6. 1 times negative 5 is negative 5. So we have 6 plus negative 5, which is 1. Now let's go to our first row, second column. So first row and then our second column here. So that'd be 2 times negative 1, which is negative 2, plus 1 times 2 is 2. So we're getting out 0. So we got 1 and 0 so far. Second row, first column. So we're now at our second row and back to our first column. So then that would be 5 times 3, which is 15. 3 times negative 5 is negative 15, so we're getting out 0. And then our final second row, second column. Second row, second column here. Negative 5 plus 6 is 1. Do you guys see how when we multiply them, we got the identity matrix? Therefore, this matrix and this matrix are inverses of each other. Now, if this is true, guys, then what's going to happen when we do B times A? Any guesses? It'll be the identity matrix. If they undo each other, it's not going to matter which way you multiply them, they're going to undo each other. Does that make sense, everybody? So we know that not all A times B's equals B times A, but if they're inverses of each other, it will be the same. It will be the identity matrix. So I'm not going to multiply it out the other way because I think you could do that on your own, and I think you guys probably understand why that works. If something undoes each other, it doesn't matter the order, it'll undo each other. Sweet. Okay, now write this down here. So an inverse of a 2 by 2 matrix. So if I just said to you, we haven't learned yet how we've learned what and how to identify if two matrices are inverses of each other. What we have not identified yet is how to find an inverse. So this is how you find an inverse. This is key of a 2 by 2 matrix. This is only how you do 2 by 2 matrices. So if you have a 2 by 2 matrix, you can use this formula. So here's matrix A with elements A, B, C, and D. We can find A inverse. So we know this negative 1 here. A to the negative 1 just means inverse, right? Is going to be this formula. So you're going to take 1 divided by A times D, which notice is the diagonal, A times D, minus the diagonal of B times C. So just that's something because you're going to have this memorized going into your exam here to find an inverse of a 2 by 2. So just notice it's diagonals, A times D minus B times C. And then you're going to take and multiply that to this matrix right here. So notice what they've done is they've swapped these. See how A and D are just swapped on the diagonal? Once again, it's diagonal related. And then B and C stay the same, but it's just the signs change to the opposite signs. So you'll swap your first diagonal. This first diagonal gets swapped. And your second diagonal just gets opposite signs. So something that's just going to take a little bit of memorization. Now this is honestly, just look at this equation here. We have 1 over A times D minus B times C, and then we're timesing that to this matrix. Based on this equation right here, can anyone tell me what they think? Remember, it's okay to be wrong, but just kind of think about it for a second. There are times when you have a matrix that we cannot find an inverse for it. There is no inverse. Can anyone think if we were doing the math when we might have a hint that there is no inverse? Yes. Very good, way to think. If A times D minus B times C is 0, won't we be doing 1 divided by 0, which is undefined? Therefore, if that ever happens, you would say no inverse can be found, basically. So, very good. Now this you're going to learn next lesson is what's called a determinant. And A times D minus B times C is a determinant, but we're not going to get into that today. So you'll see this again though. A determinant, did I say determinant? Yeah, determinant. Okay. All right, so let's find the inverse of this 2 by 2 matrix. So you'd say, oh, okay, it's a 2 by 2 matrix, therefore I can use my formula. So we're trying to get it memorized. So we have 1 over, multiply the diagonals, so 12 minus the multiplication of the second diagonal. So then we have times by the matrix, you switch your first diagonal. So this would be a 3, this would be a 4. And then your second diagonal stays the same. We've just got to change our signs. So let's go ahead and do the math here. So that would be 1/2, wouldn't it, right here? So 1/2 times by 3, -5, -2, 4. So let's go ahead and distribute. We know, we learned last time, if we have something multiplied in front of a matrix, we can distribute it through to each element. So our final answer is the inverse is going to be 3/2, -1. Do you guys see why? 3/2, -1, -5/2, and 4 divided by 2 is 2. So there, right there, is your inverse matrix. So if it's a 2 by 2 matrix, just use that formula. That's probably the quickest way, honestly. Now there is another way to find this inverse, and that is how we have to find the inverse of all other, if it's not a 2 by 2 matrix, we're going to take these steps to find the inverse for all other matrices that are square. Now this would also work though for a 2 by 2 matrix, it's just usually that formula is quicker. So here is once again the steps to find the inverse of all other square matrix. So first, we're going to write the original matrix and the identity matrix for that matrix in one big matrix with the original matrix on the left and the identity matrix on the right. So for example, if I said to you find the inverse, you'd say, okay, it's not 2 by 2, so I'm going to place this next to its identity matrix. Now, if this is a 3 by 3, the identity matrix we know would be 1s on the diagonal and 0s above and below. So on the left, I put my original matrix, and on the right, I have the identity matrix that would match up with it. Do you guys see? Just in one big matrix. Now I have put the dotted line just to separate them, but once you get really good at it, you probably won't really need the dotted line. You can just see that there's the square, there's the square. It's a square matrix, remember? So you can know that this is your original matrix. Here's the identity matrix. Now all we have to do is, now when I say all, it's back to the tedious thing, so it isn't quick necessarily, but all we have to do is then at this point we're going to take this left side and we're basically going to switch it, guys. We want to get this side to be reduced row echelon form. We want to get this to be the identity matrix on this side. So we're going to say take the left, focus on that, and we're going to get the identity matrix into reduced row echelon form on the left hand side. And then what will happen is you've got to perform those same operations over here as well, whatever you just go through, focus on the left, getting it so that there's 1s on the diagonals and 0s below, and then on the right will be your answer. That will be your third step, which is write your inverse matrix. Right there will be your inverse matrix. So it's just like going to take, some time, honestly, as you know from a couple lessons ago. Now remember, what's the order in which we get things? Now do not go about it randomly, and it dawned on me, duh. Why do we get the 1s first? Because then you use the 1s over and over. Why do we get 1s before 0s? Because to get a 0, don't you need there to be a 1 so you can make it opposite? You know what I mean? So that's why, guys, we always follow the steps I gave you. That's why you get the 1s first. So you're going to start here in this corner, get a 1. Then you're going to make this a 0, then a 0, right? Make this a 1, then make this a 0. Then make this a 1. Then we're going to be doing reduced row echelon form. So after we get 1s on the diagonal and 0s below, then we're going to get a 0 here, here, and then here. And then it will be in reduced row echelon form, and that will be our answer. All right, so let's just practice finding the inverse of a square matrix that is not 2 by 2. So here we go. Let's go through the steps here. Nothing new to us. We know how to do reduced row echelon form. So you'd say, okay, my first step is to take this 3 by 3 matrix and put it next to its identity matrix. So let's write this out. We have 1, 2, -3, -2. Just rewrite it. So the identity matrix would be 1, then 0, then 0, wouldn't it? 0, then 1, then 0, 0, 0, 1. Okay, now what we're going to do is we're going to focus on getting the left side to reduced row echelon form. So we're going to show our work, keeping our work gorgeous here. So our first step is to get a 1 right here. Isn't that done? Now we need to get a 0 here and here. Let's hit 2 birds with 1 stone. Let's take row 1, times it by -2, add it to row 2, giving us our new row 2. Let's also take row 1, let's times it by 3, add it to row 3, equaling our new row 3. So now what I would do is, once again, if you follow my steps, I think it's going to be a lot smoother for you. We are not changing row 1, correct? So I would rewrite row 1. Like we're going to be changing row 2 and 3 as we can see from our formulas. So we have a 1, a negative 2, negative 4, and we have 1, 0, 0. Okay, let's go ahead and do this. So we're going to take row 1, I'm going to change to red here. We're going to times that by negative 2. So here we go. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times negative 2. 4. 4 plus negative 3. 1. You can see how crossing them out kind of makes it nice. Kind of keeps your eyes in the right spot. Negative 2 times negative 4 is 8. 8 plus negative 6 is 2. Negative 2 times 1 is negative 2. Negative 2 plus 0 is now negative 2. Negative 2 times 0 is 0. 0 plus 1 is 1. Negative 2 times 0 is 0. 0 plus 0 is 0. Okay, I'm going to go ahead and change to brown first. So we're now going to take, and instead we're going to times by, so now we're timesing by 3. 3 times 1, oh, and we got those done. 3 times 1 is 3. 3 plus negative 3 is 0. 3 times negative 2 is negative 6, plus 6 is 0. 3 times negative 4 is negative 12. Negative 12 plus 15 is 3. 3 times 1 is 3. 3 plus 0 is 3. 3 times 0 is 0. 0 plus 0 is 0. 3 times 0 is 0. 0 plus 1 is 1. Now if you need to separate it back out, it's a 3 by 3 matrix, so right there's our dotted line. You guys see? Okay, our next step. So we have a 1, a 0, 0. Don't we even have a 1 and a 0? So now isn't our next step to make this a 1? Remember, to make this a 1, to make something a 1, you usually just times by something. So shouldn't we just take this row and times by a third? Okay, awesome. So I'm going to times by a third, and then I'm going to go ahead and just erase and then rewrite. So 0 times a third is still 0. 0 times a third is still 0. 3 times a third is 1. 3 times a third is 1. And then 1 times a third is a third. So now this will be 1, 1, and 1 third. 1 times a third is a third. Does everybody see why I got that? Okay, so now we're at the point where we get 0 in this position right here and right here, isn't it? So let's hit 2 birds with 1 stone. Look for the 1. Isn't the 1 always what you're going to use? So we're going to take row 3, times it by negative 2, add it to row 2, equaling new row 2. Let's also take row 3, times it to 4, add it to row 1, equaling new row 1. So we're not changing row 3. We're changing row 2 and 1. So I'm going to write in row 3. 0, 0, 1, 1, 0, a third. Okay, let's go do this. So take row 3, times it by negative 2. Negative 2 times 0 is 0. 0 plus 0 is 0. Negative 2 times 0. Negative 2 times 0 is 0. 0 plus 1 is 1. Negative 2 times 1, negative 2. Negative 2 plus 2 is 0. Negative 2 times 1, negative 2 plus 2 is negative 4, isn't it? Negative 2 times 0, 0 plus 1 is 1. Negative 2 times a third is negative 2 thirds. Negative 2 thirds plus 0 is negative 2 thirds. So I've done that. Changing to purple. Okay, let's go. We're taking row 3, timesing it by 4 now. So 4 times 0, 0. 0 plus 1 is 1. 4 times 0, 0. 0 plus negative 2 is negative 2. 4 times 1 is 4. 4 plus negative 4 is 0. 4 times 1 is 4. 4 plus 1 is 5. 4 times 0 is 0. 0 plus 0 is 0. 4 times a third is 4 thirds. 4 thirds plus 0 is 4 thirds. Now look, right here is your dotted line. Don't we have one last step? Make right here is 0, right? Find the 1 below it. Boom, there it is. I feel like it slaps you right in the face. Isn't that the only thing we can use? So what are we going to do? Yep. You're awesome. So we're going to take row 2, we're going to times it by 2, and add it to row 1, equaling new row 1. Row 2 times 2 plus row 1 equaling new row 1. So we're only changing row 1. And here we go. We're almost done. Row 2 times 2. 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2. 2 plus negative 2 is 0. 2 times 0, 0. 0 plus 0 is 0. 2 times negative 4 is negative 8. Negative 8 plus 5 is negative 3. Very good. 2 times 1 is 2. 2 plus 0 is 2. 2 times negative 2/3, guys, you multiply straight across. That's negative 4/3. Negative 4/3 plus 4/3. 0. Now look, you have your left side into reduced row echelon form, or the identity matrix, same thing in this instance. So our answer is, our inverse is negative 3, 2, 0. Negative 4, 1, negative 2/3. 1, 0, 1/3. Boom, there's your inverse. So it's not that it's hard, because it's all stuff we've learned before, it just takes a long time, because you've got to go clear to reduced row echelon form. Sweet stuff, though. That will work for all other square matrix. You'll just do this process here. If it's not 2 by 2, you've got to go through this. All right, now let me just show you an example of where an inverse does not exist. So it'll actually happen decently quick, so I'm just going to go through it real quick. So what if you're like, okay, to find an inverse of a square matrix that's not 2 by 2, I put it into 2, 1, 1, negative 3, 2, 1, negative 7, 7, 4, and then my identity matrix would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now wouldn't you rather switch these rows up to get 1 on the top rather than do fractions right off? So I'll hurry and switch them. I'm going to put the bottom on top, 1, 1, 4, 0, 0, 1, 1, 2, 7, 0, 1, 0, and then 2, negative 3, negative 7, 1, 0, 0. Okay, so now we're getting a 0 here and here. Let's hit 2 birds with 1 stone. So what I'm going to have you guys do, so that we can go quick, is just kind of, I'm going to write it down, and then I'm going to wait for you guys to just say, okay, row 2 is this. This is the new row 2. So won't the math be, to get a 0 here and here, take row 1, times by negative 1, add it to row 2, equaling new row 2. Then we'll also take row 1, we're going to times by negative 2, add it to row 3, equaling new row 3. Start doing the calculations. I'm going to rewrite, since I'm not changing row 1, I'm going to rewrite my row 1, and then I'm going to ask you, what's row 2? So what's row 3? So ready, start going, and write it down on your paper. When you've got like row 2, just say, I've got row 2, it's this. Anyone got row 2 all the way through? Row 3, anyone? No one's got row 3? Okay. I was thinking this would be quicker. It would have been quicker if I would have done it from scratch by myself. What else? Okay. Sweet. Okay, let's keep going here. Now isn't my next step to get a 0 here? So we're going to take row 2 times by 5, add to row 3, equaling new row 3. So I'm going to go ahead, you're going to calculate that, aren't you? Aren't you out there? I'm going to rewrite my row 1 and 2 real quick while you're calculating this. so now from here, we're in trouble because here's why. We have a 1 on 1 and zeros below. This needs to be a 1, doesn't it? You can't make 0, 1, can you? No, because we have to time. The only way we can make it a 1 is to times by something. So we're stuck. We cannot get this into reduced row echelon form. We cannot create the identity matrix. Well, if you can't create the identity matrix, you can't create the inverse. So there's no inverse. You can't create the identity matrix. So no inverse. That's all you'd say, no inverse. Awesome job, guys. We're doing good. We're actually almost done with the lesson. Last little bit here. Okay, so here's the thing, guys. Haven't we already, look at this. If I said to you solve, you've already learned how to do that, haven't you? Many different ways. We have learned how to do how to put this into its matrix form and to put it into row echelon form, right? And then solve by back substitution. We've also learned how to put it into its matrix form, go clear to reduced row echelon form, and boom, there's your solutions, right? We are just learning an additional way to solve. That is what's hard about this unit, is we are learning the same thing over and over again, just different ways of doing it. And you have to be able to do the different ways. Because what will happen is, my belief is that what will happen is on the test, they'll say, solve this by putting it into reduced row echelon form. Solve by putting it into row echelon form. Solve by, this is what's called using matrix inverses. So this is another way. So another way to solve a linear system is by using matrix inverses. Here's what we would do. Here are the steps. So if I said to you solve this by matrix inverses, you would put it into its matrix equation form. Now we saw last time how to do this. Now everybody, let's look why this would make sense, why we would split it up like this, and why this is the same true statement as this. Let's see why. So notice in my equations, I have my coefficients, 1, -2, -4, 1, -2, -4, right? 2, -3, -6, -3, 6, 15. Now, if we took those coefficients and we times by x, y, z, would that create the correct sequence here? Yes. How do we multiply things? Don't you take the first row times by the first column, everybody? So look, 1 times x is 1x. -2 times y is -2y. -4 times z. You guys see why that makes sense? And then that would create the same thing here. You would take the second row, first column, and that would create this. So look, 2 times x, -3y, -6z. Same thing here, -3x, +6y, 15z. So that would make sense. And then it's equal to the matrix 7, 5, 0. So that's how we would set it up. Now what we're going to do is we're going to call this matrix right here matrix A. And then this is our variable matrix. X, Y, Z are the variables we're trying to solve for, isn't it? So I'm just going to give it an X, like the variable X. And then we have, this is going to be our matrix B. So what would be the true statement here? Well, isn't it true that A times by X equaled our B? A times x equals b. Now you're trying to solve for the variable matrix, so what I want you to do is use algebra to get x along. Divide by A, divide by A. Have we learned how to divide two matrices? Perfect, very good, way to think. So instead of doing a division problem, we don't know how to divide a matrix. She's saying, couldn't we rewrite this as an inverse? Can't I take an exponent that's been flipped over a fraction and bring it back up, making it a negative exponent? So we have x is equal to b times by a inverse. Do you guys see? Because then I'm flipping it back on top. If it was positive 1 on bottom, I bring it to the top, it's now negative. Now here's the question though. I did the algebra. Who's to say that it's b times a inverse? Couldn't I call it a inverse times b? Yes. So it is the same thing, essentially. But we do know that it's not always true that b times a equals a times b. True? But here's the thing. We were doing the algebra. We chose to put b in front of a inverse. But we don't know if it should be a inverse times b. Because that algebra is the same, isn't it not? Putting one in front of the other. So we better just check to make sure we do the correct one first. So maybe they're the same, maybe they're not. Let's explore it. So I'm going to write this down here. So everybody, don't forget what matrix B is, because I got to give myself some room. Matrix B is 7, 5, 0, everyone. All right. So if we try to take 7, 5, 0, and then times it to A inverse. Now A inverse, remember how I said, remember this example? A minute ago, we just took this matrix right here, this exact matrix, and we've already gone through the algebra to find the inverse. We got an answer. So this is the one that I said, remember this answer. Does anyone remember by chance which one that was in your notes? So -3. Are you reading it this way? Okay. Perfect. Let's see if we can do B times A inverse. This is B, this is A inverse. So this is a 3 by 1, isn't it? 3 rows, 1 column. This is a 3 by 3. Do you guys see how the insides don't match up? So we've got to just choose to instead do A inverse times B, because then we'll be fine. So our algebra needs to be this one. So just remember that. X will always be A inverse times B. So a lot of books just say tell the kids that. I wanted to show you the algebra where it came from. So we've just got to remember that we're actually going to switch and put this on the right side. So then we have our 750 here, and now we're at a no problem because now we have our 3 by 3, we're timesing it to our 3 by 1. So do you guys see how the insides match up? So our new matrix will be a 3 by 1 matrix. Yeah, we'll always have to put the inverse first. Okay, let's write out our new 3 by 1 matrix. So our dimensions are 3 by 1. So guess what that means? Once again, you'd say I have 3 rows, but only 1 column. Now, why does that make sense? Aren't we solving X, Y, Z? Shouldn't there only be 1 column? X, Y, Z. All right, here we go. Let's figure out what X is. So you'd say this is the first row, first column. First row times to my first column. -3 times 7 is -21. Plus 2 times 5 plus 10. And then 0 times 0 is 0. So we get -11. That's our X. X equals -11. Let's go to our Y. So we would do, this is the second row, first column. Second row, first column. So that'd be -4 times 7, -28, plus, and then 1 times 5, and then -2/3 times 0, plus 0. So that'd be -23. So then Y must be -23, and then Z. So we'll do our third row, first column. Third row, 1 times 7 is 7, plus 5 times 0, plus 1/3 times 0. So we get 7. And then Z is 7. So there are your solutions. And you're done. No, we didn't just solve for X. The X is considered our variable equation, right? So it was actually X, Y, Z. We're just kind of doing some more we're writing it out in a more basic way instead of having to rewrite the whole matrix. Does that make sense? Okay, cool. So we found what X, Y, and Z were. So, because literally it just says solve. Like we're finding what X, Y, Z is. We're just using a different method. Now that seemed decently quick. The only problem is we had already done the inverse. Do you know what I mean? So that would have actually taken a long time. What if we hadn't found the inverse? What we would have had to do is say, all right, I need to hurry and find what A inverse is, and then you'd have to come back after that and times it to B. So it would be a little bit longer of a problem. This is our last example of the day, then the rest of the time will be yours to get as much homework done as possible. So it says solve the system by matrix inverse. So we'd say, okay, this is the one where we have to find the inverse of the matrix and whatnot, and then we'll set up a true statement. So let's set up our matrix equation. So remember, you do your coefficients, which are 2, -5, 3, -6, and then we'll be timesing that to, isn't the first column here X? So X, second column Y, and then that's equal to 15 and 36. There is your matrix equation. Now look, this is matrix A, this is our X matrix, our variable matrix is equal to B. So we just learned that it's going to be X is equal to A inverse times B, right? Now let's find what A, see the problem is we don't know what A inverse is. We know what B is. We can put B in right here, right now. 1536. The problem is, what is A inverse? So we're going to say, okay, first of all, let's go off to the side and find A inverse. Now there's two ways to do it. If you wanted, we could just go like this. 2, 3, -5, -6, 1, 0, 0, 1, right? Get it into reduced row echelon form. But it's also a 2 by 2 matrix. So couldn't we just use that formula that I gave you? So we could also use 1 over the diagonal times the diagonal. So that's -12 minus the diagonal times the diagonal. So minus -15. So that would be 1 over 3, wouldn't it? 1/3 times by, and then you switch these two. So that would be 6 and 2. Switch your first diagonal. And then change the sign on your second diagonal. So that'd be +5, -3. Yes, no, that's still a -6. Good catch. We only switched this diagonal right here. That would have been -6. Good catch. All right, so now let's go ahead and put our inverse matrix. So at this point, I'm going to distribute it in. So it'd be -2. That would be 5/3. Then I would have a -1. And a 2/3. So then we have a 2 by 2 times by 2, a 2 by 1. Therefore our new matrix, so this can happen, and our new matrix is a 2 by 1. So I'd say my 2 by 1 matrix will be my final answer here. So we'd have 2 rows, 1 column. Here we go. So then you would do -2. So you're doing your, first row, first column. So let's do first row times 2 our first column. -2 times 15 is -30 plus, and then you're doing 5/3 times 36. Now guys, look, you can do it in any order. 36 divided by 3, 12. 12 times 5 is 60. Do you guys see how order doesn't matter? I did that so it's smaller numbers, so I didn't even have to use a calculator. So we have -30 plus 60, which is 30, so x equals 30. Sweet. Let's go to second row, first column. Second row to our first column. -15 plus, and then I'm going to do 36 divided by 3, which is 12. 12 times 2 is 24. So then we get 9. So then y equals 9. Well, this is, oh, I see what you're saying. So yes, good point. We probably should write our answer as 30, 9. Good point. Any questions on that? Okay. Way to go. That's the end of the lesson. Does anyone need me to go back to any slides? The rest of the time is yours to work on 10.5 homework. You guys did really good.